Hey guys, this is Mrs. Lyons giving this stoichiometry thing one more shot. Here I have an example question that starts with grams of water and ends with grams of oxygen. So I want to walk you through this one more time and then maybe try to help you understand when you have to do which conversions. Okay. So first of all, I guess let's talk about when do we use what. Okay. So anytime you are converting between grams and moles, whether you're going grams to moles or moles to grams. Okay. This is when you use the molar mass from the periodic table. And you use the fact that 1 mole of your substance, whatever your substance is, let's say substance X, 1 mole of substance X is equal to the molar mass in grams of substance X. Okay, so molar mass, this is molar mass in grams. Okay, whenever you're going from moles to moles, this is where you use the mole ratio from the balanced chemical equation. So there's really only 2 types of things that we're doing. Okay, we're either converting between moles and grams or between moles and moles. Okay, so let's look at, I'm going to switch my paper around a little bit more so I have room to write. Let's look at this question. Okay, I have the equation H2O water breaks down to provide hydrogen gas and oxygen gas. Okay, so we say how many grams, so the question of grams of water is what we're looking for, must be decomposed to produce 84 grams of oxygen. Okay, so our given is 84 grams of oxygen. Okay, our given is always the thing in our question that has the number. Okay, what we're looking for in this case is grams of water. You can always tell what we're looking for if you look for the question words. How many? Okay, so how many grams of water? Now, the other thing that we've said when we're thinking about this is that we're using our mole map, right? Remember, we have grams of A can convert to moles of A using the molar mass, can convert to moles of B using the mole ratio, can convert to grams of B, again using the molar mass. Okay, we have said that if we write down our given and our unknown, our given is substance A in the mole map. So if I want to go write this, I could say that in this problem, O2 is going to substitute in anywhere that I have grams or moles of A. Our unknown is always B in our mole map. Okay, so in this case, our unknown is water. So maybe let's just completely rewrite this. Let's say we start with grams of O2. We can convert to moles of O2. We can convert to moles of H2O. And then we can convert to grams of H2O. Okay, so let's see how this works. Okay, so I'm going to start with my given, 84 grams of oxygen. Okay, over 1. Now, we know, hopefully we know, that whatever my units are, So here we have grams of O2. Those units are going to come down and be in the bottom of my conversion factor. So grams of O2 on the bottom, and moles of O2 is going to go on the top. We know that because if you look at your mole map, we start with grams of O2. The step we're trying to figure out moles of O2. Okay, we use the fact that 1 mole of O2 is equal to the molar mass of oxygen on the periodic table. And this is probably one you remember, but let's just double check. If we look at oxygen, the molar mass is 16, but we have 2 of them. So 2 times 16 is 32. Okay, our units cancel. Okay, so let's calculate. So we're going to have 84 divided by 32, so 2.625. So that gives us 2.625 moles of O2. Okay, that's the answer for my first step of my problem. All right, now I'm gonna move this down and do a second step. So the second step starts with this. 2.625 moles of O2. Okay. Now, in my second step, I'm going from moles of O2 to moles of H2O. So on the bottom of my conversion, I'm going to have moles of O2. And on the top of my conversion, I'm going to have the next step in the mole map, moles of H2O. All right. Now, anytime I have moles of one thing over moles of another, I'm going to use my mole ratio from my balanced chemical equation. Okay, so if I look up here, O2 has a coefficient of 1. H2O has a coefficient of 2. Okay, so coefficient of 2 H2O to 1 O2. Notice once again my units cancel. If I do this math, I get 5.25. 5.25 moles of H2O. So that's the answer. So if you look at your mole map, this was step 1. This was step 2. Okay, which means we have one more step. We're trying to get all the way out here to grams of water. Okay, so we're going to start with what I figured out in my last question. So 5.25 moles of H2O. Okay. So moles of H2O goes on the bottom. And then on top is going to go grams of H2O because that's the last step in my mole map. Okay. So I use the molar mass here. I know that 1 mole of water has a mass of H2O. So oxygen is 16, and I've got 2 hydrogens. So 16 plus 2.02 is 18.02 grams of water. Moles of water cancels out. I'm going to multiply times 18.02, and I get 94 point. I'm just going to do 2 places after the decimal now that I've got my final answer. So 94.61 grams of H2O is my final answer. Okay, and that is step 3. So that is how I get from moles of H2O to grams of H2O. Okay, now I want to show you something that I feel like this is the piece that some of you are missing. The steps are always the same. Okay, so let's say my question said, if 12 moles of water are used, how many grams of hydrogen would be produced? Okay, now I'm going to put my equation up here. My equation, remember, was H2O decomposes to give me H2 plus O2. Okay, now this question, my given, is 12 moles of H2O, and my unknown is grams of hydrogen. Okay, now I want you to look at this mole map that I have. Okay, and I'm gonna write it again just because I want you to kind of see. So I'm gonna cover that up. So grams of A, moles of A, moles of B, grams of B. Okay, now if you look, I am starting with moles of A. So I do not need grams of A. I don't need that first step. I'm starting here with moles of A. And I'm finishing with grams of B. Okay, so if you look at that, if you look at what we just did, okay, basically it would be like starting on step 2. And then you're going to do this exact same math. You're going to start with moles. You're going to use the mole ratio. You're going to get moles of B. Then you're going to come down here with moles of B, use the molar mass, and figure out the grams. Okay, so the thing that I'm trying to get you guys to see, and I'm gonna do this one. Okay, so A is H2O, so moles of H2O. B is H2, so moles of H2 to grams of H2. So this is my mole map for this question because I'm starting at moles of H2O. All right, so I'm going to start with 12 moles of H2O. Now, I don't need grams here. I've got moles, so moles has to come down here. And then on the top, okay, so I've got moles of H2. On the top is going to go moles of H2. So moles of H2 is where we're going in that first step. We're going to look at my balanced chemical equation because I've got the mole ratio. So 2 moles of H2O, 2 moles of H2, which gives me 12 moles of H2. Okay, units cancel. So this is the answer to my first step. Then I'm going to go 12 moles of H2. On the bottom, I'm going to have moles of H2. All right. And then up here on the top, see where I'm going? I'm at moles of H2. Next stop is grams of H2. And if I have moles and grams, I know that 1 mole is equal to the molar mass. So hydrogen is 1.01. I have 2 of them. So that's 2.02 grams of H2. Moles cancel out. If I do this math, I'm going to do 12 times 2.02, and I get 24.24 grams of H2 as my final answer. So what I've been trying to get you guys to see here is that you're doing the same steps over and over and over again. Okay, you're doing the same steps. You just have to figure out where you start and where you stop. Okay, so I hope you guys that helped a little bit. I know we have a test coming up on this, and I really want you to understand what you're doing. So I hope that helps. I will see you in class. Take care of yourself.